Hi, my name is Martin. I'm one of the three developers behind the LITEQ library. LITEQ was developed in order to simplify coding against Sparkle endpoints. We can help you to explore your RDF data, to query it, and we can turn the classes inside of your RDF data into classes usable from F#. So LITEQ is a normal library. To install it, just use the NuGet package manager. Search for LITEQ, hit the install button, and all the dependencies should resolve itself. The README file will open up and point you to the project documentation and other useful websites. You can then go ahead and create the type representing your store. LITEQ comes with two different type providers, the NPQL type provider and the property-based type provider. Let's focus on the NPQL type provider right now. The NPQL provider is best used when you have a schema already present with your data. The static parameter shown here points to a configuration file which has all the necessary values to configure LITEQ. These values include the server URI pointing to a Sparkle endpoint, the update URI pointing to a Sparkle endpoint accepting update queries, the schema file which either contains a pre-downloaded RDF XML serialized version of the schema, or you can LITEQ download its own schema, and the prefix file which contains prefixes used to beautify the types that we create. Such prefixes look like this. For example, we have the fourth prefix and just the full URI. Okay, so my configuration is under my documents folder. And that should be it. Okay, so let's actually start working with our data. We're doing so by writing NPQL expressions. An NPQL expression can start with the RDFS class or RDFS property. So in this case, let's actually choose fourth agent. From there we have four basic options. We can choose a property navigation, a property restriction, the extension, and the subclass navigation. The property navigation actually moves from the RDF node representing fourth agent in the graph to the property, such as fourth account. And from there you can continue to a class again with, in this case, fourth online account. The property restriction restricts the instance set. So essentially this expression would mean that we would want all fourth agents that have a fourth account relation present. Like mentioned, the extension essentially evaluates the expression. In this case, we would simply get a sequence of all fourth agents inside our triple store bag. And the subclass of navigation essentially moves from the RDFS class to a more specific class through the subclass of navigation. For example, from fourth agent to music artist. Now, of course, if you would know that we want music artists back, we could have simply started our expression with music artist and then used the extension to evaluate the expression. Like already mentioned, we get back a sequence of music artists in this case. So we can now use a for loop to iterate over it. And let's print out the artist URL and the name. Okay, so let's test it if this actually works. And you can see that it produces meaningful output. You can also create your own types with LITEQ. So let's create a new music artist. For this, we're saying that the music artist type should basically be alias for the music artist RDF node and the intention of this node. So please note that actually this intention is the same thing that's being returned by the extension in the sequence. We just basically created an alias for it. So let's instantiate our new artist. And let's actually assign it a name. And this is it. These two statements essentially fire off the Sparkle update queries that are necessary to actually create these types. The extension will then recognize the type and actually return it into this sequence. Okay, so now let's talk about the second type provider, the property-based one. The idea behind the property-based type provider is very different from the NPQL-based. The property-based type provider is intended to be used when there's no schema available. So its idea is that you actually specify types based on the properties that they should have. If I want to specify a new music artist type, I essentially start listing properties, such as for name. I now want to add another property, and the list of possibilities is already severely reduced. This is because we only observed certain properties together in combination with for name. So let's choose for mate. I can now choose between a named and an unnamed variant of this type. The unnamed variant is essentially a more specialized RDFS resource. It will contain values for name and for mate, but it won't contain anything else. So let's iterate over the extension of the newly created music artist type. And as before, let's print out the URL and the name. Now, if I also want to access the biography, I actually have to specify this as a string. So this would be okay. Let's hit the start button and check if it works. And we can see that it actually works. Okay, so now let's talk about the named variant. The named variant allows us to specify another RDF type that all the instances that belong to this music artist type should also have. It also allows us to search through the store whether there is really no schema information available, because maybe there are some properties that state their domain. And if they are, we can automatically add them to the type. This, for example, is the case with the biography property, as you can see here. And with that, it's much easier to work with the type. So let's again start it and test it. And again, we see that it works. Okay, so this was basically a short introduction into LITEQ. Thank you for watching, and please let us know what you think. Goodbye.